So, when do you need a harmonic study, like to do estimated versus a full study? And just because I have harmonics on my meter, do I have a problem? These are the kind of questions we get asked a lot around harmonics.
Sure.
So, if I were to do a harmonic analysis more formally and do, more analysis on the power system, how do I know when to make that decision? If I add, let's say, on a 3 MVA transformer and I put a 30 horsepower drive, do I need to do a full harmonic study? No, the answer is no. And I think most people would realize that. But it's as you add more harmonic loads to the system, or you add power factor correction capacitors to the system that could excite resonance, you need to start thinking about, when do I need to do a harmonic study? And so I'm going to show you a couple graphics here that talk a little bit about when we want to consider that, especially around power factor correction. So, rules of thumb, especially when we're applying capacitors, if there's harmonics on the system, and today we can pretty much assume that there's going to be harmonics on a power system. So if the harmonic distortion without the capacitor is greater than 10%, or the voltage distortion is greater than 3%, we do want to consider putting in a harmonic filter instead of a straight capacitor, because otherwise we can amplify the harmonics. Are there third harmonic currents on the system? So is this a single phase type load scenario with a lot of LED lights or computers or other single phase loads? If the harmonic distortion of the third is greater than 0.2, or in other words 20%, then yeah, we're going to have to consider putting in a third harmonic filter, which is typically tuned to 2.67. In some of the other videos we talk about why we would tune filters to different levels. If we don't have a lot of third harmonic, then we'll put a fifth harmonic filter, which is going to be 4.2 or 4.7. And then if the short circuit over the load is low, what does that mean? That means I have a weak source. Then I'm going to put in a detuned filter bank, and it's going to even be lower pretty much, 3.7 to 4.2. If it's not low, meaning I have a pretty stiff source, I can use that 4.7. Why is that the case? Because if I put a harmonic filter on a really weak source, I'm going to draw in all kinds of harmonic current, and I may overload the filter. Are there any large VFDs? If yes, then the smallest cap size should be greater than 40% of the largest VFD size. So 100% or 100 horsepower VFD, you'd want the smallest cap size to be 40 kVAR. And the reason is because the power factor on drives is pretty high, so we want to consider having enough capacitance on the power system in that filter form to absorb the harmonics. Otherwise, if we have a really small filter on the system, we may overload it with the larger VFDs. Are there any soft starters? If so, use a filter cap or use a standard cap in line with electromechanical bypass with a time delay. What does that mean? Soft starts basically look like VFDs, but only for about 5 to 10 seconds. So if we're going to have a soft start on our system, we can create resonance, and we've seen it before, where we excite this resonance and have problems. So you need to really put in filters rather than straight caps, because otherwise you amplify with harmonic resonance. And is the total capacity greater than 15% of the transformer kVA? If yes, check for resonance. So all these things are considerations. And then if you take it to the next step, let's say I have a 1000 kVA transformer. If I have over 150 kVA worth of harmonic load, I really need to think about resonance, first of all. If I have in that 15 to 20% load, I really should also be doing full-blown harmonic analysis. And as I get up closer to, say, 30 or 40% of that transformer size, I really want to understand with harmonic analysis where those harmonic currents are going to go. Anytime I'm applying power factor correction, though, like we showed in that table, we really want to consider which harmonics I see and where they're going to flow and whether or not we're going to create resonance to make sure we don't cause damage to the power factor caps or to the power system itself with harmonics.